Morning to all. Today we are going to discuss a course on robotics. Okay, and my name is Mr. P. Satya Krishna. I am from mechanical department. And before going to the course, briefly discuss about the course objectives, course outcomes. So the objective of this course is mainly to provide theoretical and practical understanding of robotic engineering, which including manipulators, dynamics control and its applications, and also supporting devices like sensors. All can will be discussed in this course. And coming to the course outcomes, the first outcome is understand the different types of robots and basic components of industrial robots. And the second outcome is model the forward and inverse kinematics of robot manipulators. And third outcome is analyze trajectory planning techniques and obstacle avoidance methods in robotic systems. And fourth outcome is explain the significance of various actuators, sensors, feedback components used in robotics. And the fifth outcome is describe the development of robots in manufacturing systems and the use of robot programming languages. And coming to the portion of this robotic syllabus, in unit 1 we will discuss about the automation and robotics and its components of the industrial robotics, its architecture precisions will be discussed. And coming to the unit 2, we will discuss mainly about the motion analysis, which consists of various methods like rotation matrices, equivalent axis angles, Euler angles, composition total matrix, homogeneous transformations. And we also discuss about the manipulator kinematics, where we will dealing with the assignment of frames, H transformation matrix, joint coordinates will be discussed, and also forward and inverse kinematics problems also will be discussed on industrial robotics. And coming to the unit 3, we will discuss about the differential transformation of manipulators, Jacobian problems, Lagrange Euler neural formulations, slew motion, interpolated motion, straight line motion. And unit 4, we will discuss about the robotic actuators and feedback components. In that, we will discuss about the actuators like pneumatic, hydraulic, electric and stepper motors, and this comparison of these actuators, feedbacks and components, position sensors, position meter, potentiometers, resolvers, encoders, velocity sensors, tactile and range sensors, force and torque sensors, and effector tools will be discussed. And coming to the unit 5, it is mostly dealing with the robot application in manufacturing. Okay, in that mainly we will discuss about the material transfer, that is applications like in material transfer, material handling, loading and unloading process, so spot and continuous arc welding and spray painting. And we also discuss about these robotic applications in assembly. And finally we'll discuss about a few topics on robotic programming also. And coming to the textbooks, we preferred is Industrial Robotics by Groover and Introduction to Industrial Robotics by Ramchandran Nagarajan. And coming to the references, we discuss Robot Dynamics and Controls by John Willey and Robot Analysis and Controls by Willey Inter Science. So coming to the unit 1 introduction part, that is robotics and automation. First we will discuss about what is robotics. Robotics is an art and science of design and integrating objects which support devices and systems to perform precise and efficient tasks in industrial and human applications. A robotic system, therefore, it not only consists of a robot, but also the supporting devices such as sensors, actuators, controllers, and end effectors that enable robots to assist human endeavors. So when coming to the brief history, This word robot concept was first introduced in 1920 by Carl Seppek, which evolved from the simple feedback mechanisms to advanced programmable systems like Puma robot, that is programmable universal manipulation arm robot. And this robot word has been come from the sage word robota, which meaning is a forceful labor. Before in 1960s, this robot usually meant a man-like mechanical device which is capable of performing human tasks or behavior in a human manner. Today, robot exists in many forms and are extensively used in industries such as automobile manufacturing for tasks including welding, painting, assembly, and material handling operations. And when coming to the definition of a robot, there may be various definitions, but mostly the definition of the robot is given by the Robotic Institute of America. They have defined a robot is defined as a reprogrammable, multifunctional manipulator designed to move material, parts, tools, or specialized devices through various programmed motions for the performance of a variety of tasks. Or it also defined as industrial robot is a defined as a number of rigid links connected by joints of different types that are controlled and monitored by computer. So, a scientist called Isaac Asimov, he has proposed a three laws of robotics, where he later added a zeroth law. And the law one, he was proposed that a robot may not injure a human being or through inaction, allow a human being to come to harm unless this would violate a high order law. Law 2. A robot must obey orders given to it by human beings, except where such orders would conflict with a high order law. Law 3. A robot must protect its own existence as long as such protection does not conflict with a high order law. And Law 0. A robot may not injure humanity or through inaction allow humanity to come to harm. And coming to the automation and robotics, these are the two technologies which are closely related. In industrial context, we can define this automation as a technology that is concerned with the use of mechanical, electronic, and computer-based systems in the operation and control of production. For example, we can see the technology includes these transfer lines, mechanized assembly machines, feedback control systems, NC machine tools. And we say this robotics is a form of industrial automation. And coming to the types of automation, the first one is a fixed automation, or we can call it as also a hard automation. This fixed automation refers to the use of special purpose equipment to automate a fixed sequence of processing or assembly operations. It is typically associated with high production rates and is relatively difficult to accommodate changes in the product design. This is also called as hard automation. For example, we can say take that GE manufactured approximately 2 billion light bulbs per year and uses fairly specialized high-speed automation equipment. So we can say this fixed automation is also a type of mass production where it makes sense only when product designs are stable and product life cycles are long. So the machines used in this hard computation applications are usually built on the building block or in a modular principle. If we come across the example of the fixed automation, we can see that transfer lines and welding in automobile engine manufacturing and automatic bottling and filling plants, mechanical presses for sheet metal stamping. And when we come across about the advantages in this fixed automation, this is maximum efficiency, low unit cost, automated material handling, fast and efficient movement of parts, very little waste in production. Coming to the disadvantages, large initial investment, inflexible in accommodating product and variety. And next we come to the programmable automation. This programmable automation is the which is equipment is designed to accommodate a specific class of product. That means we only the specific product has been based on the batch production, for example we can say, and this processing or assembly operations can be changed by modifying the control program. That is what we can see, it is particularly suited for the batch production, or the manufacture of a product is medium lot sizes. So the example for this type of automation will comes under this CNC lathe, which produces specific product in certain product class across to the input program. And this in programmable automation in reconfiguring the system for a new product is time consuming, because it involves reprogramming and setup for the machines and new fixtures and tools. That's why this is mainly used in as a batch production. And the examples that comes under this programmable automation is numerically controlled machines, industrial robots used for welding or painting, NC punching machines, injection injection molding machines with programmable cycles, etc. And when we come to the advantages, we can see the flexibility to deal with variations and changes in product, low unit cost for large batches. And coming to the disadvantages, a new product requires long setup time and high unit cost related to fixed automation. And the third type of automation is flexible automation, or you can also say it is a soft automation. The in flexible automation, the equipment is designed to manufacture a variety of products or parts, and a very little time is spent on changing from one product to another. Thus, a flexible manufacturing system can be used to manufacture various combination of products according to the specified schedule. With a flexible automation system, it is possible to quickly incorporate changes in the product or to quickly introduce a new product line. For example, Honda is widely credited with usable flexible manufacturing technology to introduce 113 changes to its line of motorcycles, the products in 1970s. So this flexible motivation gives the manufacturer the ability to produce multiple products cheaply in combination than separately. For example, you can see as automated material handling system with AGVs, smart factories, that is Industry 4.0 systems. When we come to the advantages, it is a flexibility to deal with product design variations, customized products. And when we discuss the disadvantages, large initial investment, high unit cost related to fixed or programmable automation. And if you see the graph, this graph shows the production volume which has been shown in y-axis and the product variety in x-axis. If you see this graph, it shows that the fixed automation is showing with high production volume and low productivity rate, which is basically used for the mass production. Whereas this flexible automation, this is used as a medium product volume, medium product variety with quick over change between the products. And if you to see the programmable automation, in this program automation, there is a low production volume, high productivity rate, suitable for the batch production. So, if we come across these three automations, if you see the robotics, this robotics is lying mostly at the programmable automation and the flexible automation. So, we can say this robotics is a bridge between programmable and flexible automation, which improves adaptability and efficiency. So, hence we can say an industrial robot is a general purpose programmable machine which possesses certain human like characteristics. So, now we discuss about the applications of robot in present, future, and if we come across the present applications of robots, we see the first one as the material transfer applications. So here in this, robots are used to move materials such as raw parts, tools, and finished products between workstations, reducing human effort and increasing productivity. If the second one is machine loading and unloading. This Robots load workpieces into machines like CNC machines, milling machines, and presses, and unload finished parts, ensuring safety and consistency. The third one is processing operations. These robots perform various manufacturing processes with high precision and repeatability. So, spot welding. The in under processing operations, we come across this spot welding for joining metal sheets in automobile body manufacturing, continuous arc welding, which is used for long and continuous welds in pipelines and structures, spray coating, which is uniform application of paint or coatings in painting industries, drilling, routing, and machining to make accurate hole making and material removing, and grinding, polishing, deburring, and wire brushing for surface finishing operations to improve product quality. And also, these are also used in laser drilling and cutting for high precision cutting and drilling for metals and composites. And fourth one is assembly tasks. So this robotics assemble components such as electronic parts, automotive components, and mechanical sub-assemblies with high speed and accuracy. And the fifth one is inspection, automation, and testing. These robots equipped with vision systems and sensors inspect products, perform quality checks, and test components automatically. So, future applications, if you come across the future applications of robotics, first one is intelligence. This future robotics will have an advanced artificial intelligence to learn, adapt, and make decisions autonomously. The second one we see is sensor capabilities. So this is an improved sensor, so will allow robots to see, hear, feel, and respond accurately to their surroundings. If you see third one, that is telepresence. That is, robots will enable humans to operate remotely in dangerous or distant locations using real-time feedback. The fourth one is mechanical design. Robots will be lighter, more flexible, and more human like in structure and movement. Fifth one is mobility and navigation. Robots will be capable of walking, climbing, and navigating uneven terrains. Next, sixth one is universal gripper. These future grippers will handle objects of different shapes, sizes, and materials without tool and changes. The seventh application is systems integration and networking. Robots will communicate with machines, computers, and other robots through advanced networks. Eighth one, flexible manufacturing systems. So, robots will be integral parts of highly flexible and automated manufacturing setups. Ninth one is hazardous and inaccessible environments. Robots will work in nuclear plants, disaster zones, toxic environments to reduce human risk. And tenth one is underground coal mining. Robots will perform drilling, inspection, and rescue operation in mines. 11th one, firefighting operations. These robots will assist in detecting fires, rescuing people, and handling hazardous fire situations. And 12th one, robots in space, where they are used for the satellite repair, space exploration, and construction of space stations. Third one is security guards, where robots will monitor premises, detect instructions, and assist in surveillance. A fourth one is garbage collection, waste disposal. Robots will sort, collect, and process waste efficiently. 15th one, household robots. These robots will assist in cleaning, cooking, and elderly care at homes. And finally, medical care and hospital duties, where these robots will assist in surgeries, patient care, rehabilitation, and hospital logistics. So these are the present and future applications of the robots. And now coming to the classification of a robot, this robot has been classification on three categories. The first one is based on configuration, based on application, based on control. If you see this based on configuration, these robots are classified as Cartesian, cylindrical, spherical, articulated, and SCARA. If you see the based on application, these robots are classified as industrial robots, service robots, medical robots, military robots, and mobile robots. So, based on this application, our course is mainly focused on the industrial robots. And when coming to the classification based on control, the first one is manual, semi autonomous, and fully autonomous. Thank you.